we come to the most important session of this chapter, that is the inverse of the function. In the examination point of view, you can expect a 6-mark question from this part. So it's very important that you understand this concept in its fullest. So let's together discuss on what is the inverse of a function. Okay? So here I define a function f from x to y. Okay? Let f be a function from x to y. I shall just write this y once again. Okay. Let f be a function from x to y. Now let me draw an arrow diagram to represent this. So this is the set x and this is the set y. And f is a function from x to y. Okay. Now let x be a small x be an element of where the set x, which is mapped under the function f. You get it as f of x, right? Now I may write this as y is equal to f of x. What is this y? Y is a element of capital Y, that is the set y. So y is equal to f of x. Let it be like that. Okay. Now what is the inverse? Okay. There are certain conditions that we have to discuss. Certainly, of course, when we discuss the invertibility of a function, there are certain things which we have to discuss. But before moving into the conditions, I am just explaining to you what is the inverse. Okay. So, here the function is from x to y. Now, x is an element of x and y is an element of y. Here x is the element of, I can say it is much clearly as the domain of the function. X is an element of the domain of the function. Y is the element in the codomain of the function. Now y is becoming into the range also. Okay. So x is element here and y is an element here. Y is what? It is a function that is mapped under the given function f. So I have y is equal to f of x. Okay. Now, where I find the inverse, what do you mean by inverse? The pre-image of y to x. Did you understand that? It is the pre-image of the y to this side, to this x. Okay. So, inverse happens from where to where? Inverse happens from y to x. Inverse happens from y to x. Now this inverse is also a function, right? Now whatever I have discussed on f must be there in f inverse also, which means this invertibility, now I am coming to the condition. The invertibility of the function is only possible when the function is 1, 1 and onto. Right? The invertibility of the function is possible only when the function is 1, 1 and onto. So the definition is coming up like this. If f is a function from x to y is invertible, is an invertible function. What do you mean by invertible? It is 1, 1 and onto. The function f is 1, 1 and onto. So if f is a function from x to y and which is invertible, then there exists an inverse. An inverse denoted by f inverse. Right? Denoted by f inverse. F inverse is meaning the inverse. Okay. So if I take this f inverse as a function g, so I can say that there exists an inverse g such that g is a function from where to where? From where to where? G will be a function from y to x. Understood? G will be a function from y to x. So I repeat, if f is a function from x to y and it is invertible, that means it is 1, 1 and onto. That is the condition of invertibility. Only if the function is 1, 1 and onto, we say that it is invertible. So, if f is a function which is invertible from set x to y, then there exists the inverse. I took it as g. F inverse is not treated like this. I took that inverse as G. G is a function from where to where? Y to X. Such that there exists one more condition coming up. So this is all about invertibility, but such that we have already studied the composition function, right? So that GOF will give you I of X. Ix means identity function of X. It is nothing simple. That is when you apply GOF. G is the inverse. When you apply GOF, you must get simply X. When we do the problem, you will understand it in more. Right now, in the definition, I am putting it as GOF is the identity element of X and FOG will be the identity element of Y. That is, when you apply FOG, you will get it as Y. Okay, we will see that what it is in our problem session. But simple to understand, this FOG and GOF. GOF must give you X and FOG must give you Y. Now, what does this meaning? GOF and FOG gives you an identity value. That is, G is the inverse of F. When I write it like this, F is the inverse of G. So GOF and FOG giving you the identity elements, meaning they are inverse to each other. G is the inverse of F and F is the inverse of G. That happens when GOF gives the identity value X and FOG gives the identity value Y. Okay, so if so, GOF giving you X and FOG giving you Y, which means that G is the inverse of F and F is the inverse of G. So here, once again coming to the function, when we discuss about the inverse of the function, here F is a function which is invertible. F is a function defined from set X to Y, which is invertible. What do you mean by invertible? It is 1, 1 and on 2. So whenever you are asked to check whether the function is invertible, what does that mean? You need to check whether the function is 1, 1 and on 2 or surjective. Surjective means 1, 1 on 2 function. Okay, so invertible. F is an invertible function such that there exists an inverse. There exists an inverse G from Y to X. From where to where? Y to X. Such that GOF gives you X and FOG gives you Y. Now, let me explain one more thing here, which is very important in the when you do the problems. Okay, here you have the element X. Here you have it as Y is equal to F of X. What happens then? This X undergoes the mapping with the function F to give you Y is equal to F of X. Okay. Now coming to the inverse. Inverse happens from where to where? From here to here. Right? That means from here to this side. From here, what is that you are having? Which is the element that you are having? You are having it as Y. Right? So, F inverse of Y. You get me? Here you got it as Y is equal to F of X. From where to where? From here to this side. Y is equal to F of X. X is mapped under the function F to give you Y is equal to F of X. Now I am coming from this side to this side. Okay. From where to where? I am talking about F inverse. F inverse is what? G. I can write F inverse as G also because in the definition you have that G. So F inverse is same as the function G. Now F inverse of what? Here the element is what? Do you have an X here? No. You have the element Y here. So F inverse of Y. When it comes from here, the Y is having the pre-image what? X. So F inverse of Y is equal to what? You get me that? F inverse of Y is equal to X. So here I can say that Y is equal to F of X. Y is equal to F of X. This simply implies from here, what can I say? F inverse of Y is equal to X. Am I clear to that? This is very important point which you have to keep in mind. What did I say? F is a function from X to Y. The inverse is from Y to X. If it exists means what? It is invertible. Invertible means what? It is 1, 1 and on 2. Okay, so y to x. Y to x means what? Y is having the element small y. Y is equal to f of x. All the elements inside the set is y elements. Right? So f inverse happens from here to this side. F inverse of what? Y gives you what? X. Right? So from here to here it is invertible. Then the inverse is what? F inverse of y equals x. Okay, so this is a very important thing that you have to keep in your mind. If y is equal to f of x, then which implies f inverse of y is equal to what? X. This is x, this is f of x, and when it comes from this side to this side, it is inverse f inverse of what? Y. F inverse of this y gives you what? This pre-image. Right? The value of f inverse of y will be what? This x. Can it be anything else? No. So this is how it happens. So f inverse is a function from y to x, and f inverse of y is equal to x. Okay, so that is it. So I can give the definition of inverse, like what? If f is a function from x to y is an invertible function, which invertible function means what? It is 1 1 and on 2, then there exists the inverse. If it is 1 1 and on 2, that is it is invertible. There exists another function, that is the inverse function, which is denoted as g, as a function from y to x, such that GOF is x and FOG is the identity element in y. You understood that? You will understand it in more in the next example given. We will see how to prove that it is invertible and how to find the inverse. Okay? I hope this part is clear. Okay. Let's see an example to find the inverse of the function. It's quite simple. There are two methods to find the inverse. I shall give you both the examples here for this particular, example. Okay. So, consider f being a function from closed interval -1, 1 to r given by f of x is equal to x by x plus 2, and it is asked to find the inverse. Now, as I have told you, to find the inverse, the function must be 1, 1 and on 2. Right? So, in order to prove that it is 1, 1 and on 2, all the while we have already done it to proving 1, 1 and on 2. So, to prove it 1, 1, what will I do? Let x1 comma x2 belongs to the domain of the function. Which is the domain of the function here? Closed interval -1, 1. Then, such that f of x1 equals f of x2, which implies x1 by x1 plus 2 is equal to x2 by x2 plus 2. Cross multiplying x1 into x2 plus 2 gives you x2 into x1 plus 2. Now this implies x1 x2 plus 2x1 is equal to x1 x2 plus 2x2. Now if you look at this and this cancel, further 2 and 2 cancels, which implies x1 equals x2. Therefore the function is what? 1, 1. We know that. This is how we prove for 1, 1. Now to check for onto. I know y is equal to f of x. That is, y is equal to what? F of x is x by x plus 2. Now I express this expression y is equal to x by x plus 2 in terms of x is now expressed in terms of y. So for that, this implies y into x plus 2 is equal to x. This thing is familiar to you actually, which implies yx plus 2y is equal to x. Combining the x's together, yx minus x is equal to negative of 2y, which implies x into y minus 1 is equal to negative of 2y, which implies x is equal to 2y by 1 minus y. What did I do? I took this negative down to the denominator to get it as 2y by 1 minus y. Now here, once I get the value of x in this manner, what is the next thing what I do here? For corresponding to every y, you remember that? How did I prove ontoness? Corresponding to every y that belongs to the codomain of the function, there exists an expression of this kind such that f of this expression gives you what? Y. So f of this expression means what? 2y by 1 minus y. F of 2y by 1 minus y. What is that? It is, what is f of x? F of x is x by x plus y. That is 2y by 1 minus y, the whole divided by x. In the place of x I write 2y. 2y by 1 minus y plus 2. This expression is like this, so that it's in the denominator and the denominator, this part and this part is the same. When I cross multiply, then 1 minus y cancels. 2y plus 2 minus 2y, so that 2y minus 2y cancels. Further 2 and 2 cancels. What will I get? Y. Right? So that when I get this as y, I write that f is on 2. We write it as f is on 2. Now one thing children, here I write f is on 2. Right? F is on 2. So 1 1 ontoness is proved and hence it is invertible. Now let me ask you something. I don't know whether you have thought about this, but now you have to think about it. That is, here the function is from the domain of the function to the range of the function. That is, I'm sorry, the domain of the function is the codomain of the function from which I deduce the range. Anyway, the codomain is same as the range. That's why I wrote it as the range of the function. Anyway, it is to the codomain of the function. Now, when it is 1 1 and on 2, and when I say that it is invertible, here I got a value of x is equal to 2y by 1 minus y. Do you remember me telling you y is equal to f of x implies f inverse of y is equal to x. You remember this? F inverse of y is equal to x. Now see, just have a look. I'll give you a big eye opener here. Here f inverse of y is equal to x you get. Here you get x is equal to this, right? Now, what is our f inverse of y? Just compare these two equations. Just compare it. You will simply get the inverse. What is the inverse? X is equal to 2y by 1 minus y. From here I have f inverse of y is equal to x. X and x are the same. So what is f inverse of y? What is f inverse of y? This implies f inverse of y is equal to 2y by 1 minus y. Isn't it or not? Simple it is. It is very simple. It is very quick also. So, from here I can just take out the inverse. That is, x is equal to this. X is equal to f inverse y. Both the sides have x. Then I can simply write f inverse of y as 2y by 1 minus y. Now you might ask me, if it is f inverse of y, why it is f inverse of y? Can't it be f inverse of x? Sometimes the question in the question it will be to find f inverse of x. Definitely you can write f inverse of x here. See, it is 2x by 1 minus x. Got it? Simply, in the terms of y, you have plus 2y by 1 minus y. Here it is 2x by 1 minus x. 2x by 1 minus x. That is f inverse of y and f inverse x. Both are the same. Only thing is that variable is changing. Now see, here I had that x, right? I'm just explaining the same thing. Okay, here I had that x, here I had that f of x, which is same as my y. Now this was the function from this domain of the function to the codomain of the function, which was 1 1 and on 2. Now talking about the inverse, it is a function from where to where. Now this becomes the domain for the inverse and this becomes the codomain for the inverse, f inverse. Now here I have got it as, see, x is equal to, what is this x? This x belongs to the domain of the function. Now when you talk about the inverse, it is in the codomain of the function. So x is equal to 2y by 1 minus y. That is, this y is taken from this particular set. Got it? So this is the function. This is the functional value of a function from this set to this set. This being the domain, this being the codomain, this is the function, the value of the function from this set to this set. Am I clear to this point? You want me to explain once again? Listen, if x is given here, this part is this y. Y is taken from this set, right? This set, right? So, 2y minus y gives the value of x. So, where is this function acting on? In this set. right? Now this 2y minus 1 minus y is the functional value from this side to this side. Now this side to this side means what? This side to this side. That is, this is domain, this is the codomain, this is F inverse. Right? So F inverse is equal to what? The function value is 2y by 1 minus y. So this is the methodology how you prove it. That is, once you prove it is 1, 1. This is on to. Then you have that y is equal to f of x, which implies f inverse of y is equal to x. Let that be the second part. Already we had got the first part. Now comparing 1 and 2, I can write f inverse of y is equal to what? 2y by 1 minus y. Therefore, the inverse f inverse of x is equal to what? 2x by 1 minus x. So this is the first method. This is the first method. Now let me discuss the second method using our FOG and GOF. Using the fog and goff. I don't use it, but since for just change, I termed it as fog and goff. So using FOG and GOF, I'll just show you how to find the inverse. Okay. So I hope this is clear, all of you. So let's move on to the second method. Okay. Now coming to the second method. I hope the first method is clear. Coming to the second method. The first thing that you have to do is, second method I told you already, we are finding GOF and FOG. So, in order to find GOF and FOG, the first thing is that express this function y is equal to x by x plus 2. The x is expressed in terms of y. I express this entire function. This is y is expressed in terms of x. What I do here is, taking this function, I will express x in terms of y. So exactly this is what I am going to get, what I have found here. But still I am redoing it. Y into x plus 2 is equal to x. Yx minus x is equal to minus 2y. That is, x into y minus 1 is equal to negative 2y, which implies x is equal to 2y by 1 minus y. What did I do? The entire expression, the function that is given here, y is equal to f of x. The function y is equal to this expression. I express x in terms of y. That is what I have to do. Express x in terms of y. And I consider this as my function g. G is a function in terms of y, right? G of y. So this I have taken it as g of y. Now let me find FOG. FOG means which is the function that is acting first? G, right? F of g, that is f of g of y. G is a function of y. FOG of y. That is f of 2y by 1 minus y. What is g of y? 2y by 1 minus y. Now f of this, substituting this in f of x, what do I get? That is 2y by 1 minus y by 2y by 1 minus y plus 2 is equal to, further I cut off the denominators, 1 minus y, 1 minus y, I get both the place the same. 2y plus 2 minus 2y, 2y minus 2y cancel, further 2 and 2 cancels, what will I get? Y. That is FOG is giving me y. Right? What is this y? This is same as IY. This is what I told. Y is simply what? IY. I'll simply write it as IY and consider it as the identity value of y. Identity in y. Now what is GOF? GOF means what? G of f of x, right? G of f of x. That is G of f of x is what? X by x plus 2. Now substituting this in the in G of y. In the place of y, I'll write what? X by x plus 2. This gives me 2 times x by x plus 2 by 1 minus x by x plus 2. Right? That is g of this. In that place of y, I have just replaced with this function. So this gives me 2x divided by This cancels off, denominator becoming the same as I have discussed earlier. When I cross multiply, x plus 2 minus x. Now x and minus x cancel, further 2 and 2 cancels, and I get the value as x. Now this is I of x. Can you remember what I have said in our definition of invertibility? If g of f gives you x and f of g gives you y, it is simply states that it is invertible. And the inverse is what? This g is my inverse. F of g gives you iy. G of f gives you ix, the identity value. That is, g is the inverse of f and reverse, f is the inverse of g. So here we are asked to find the inverse of f. So what is the inverse? G is the inverse. From here I conclude, since f of g equals g of f, right? F of g, if I want to completely write this, I must write f of g gives me what? Iy. And g of f gives me what? Ix. Then it is invertible and the inverse is what? 2y by 1 minus y. That is f inverse of y. F inverse of y is 2y by 1 minus y and f inverse of x is 2x by 1 minus x. So once I get to this particular expression, I can readily write, therefore f inverse of x is equal to what? 2x by 1 minus x. I'll write the inverse exists and f inverse of x is this. Right? So there are two methods. One, by choosing it as 1, 1 and on 2. I always prefer this. But this way is also fine. This way also you can do. There is nothing wrong in doing it. But this is somewhat much easier than going with that. But some people find that to be easy. Some people find this to be difficult. So whichever way you want, you can do it. But I certainly prefer the first methodology. Okay. So this way also you can do. But this will be fine. Okay. So that's with an example giving you two methods. So just have a look of it.